Percent, what do you do with a percent? Change it to grams. You've got 5.1 and 54.2. All right, so 5.1 grams of H, and what I say, 54.2 grams of O. Change grams to moles. Grams, moles, and grams, moles. 1 and 12, 1 and 1, 1 and 16. That's going to be 5.1 moles. Of course, that we can calculate. So 40.6 divided 12 is 3.383 moles, and 54.2 divided 16 is 3.383 moles. All right. So what do we do from there? Which is, okay, 3.383 is 1. Divided by 3.383 is 1. Divide here by 3.383, and what'd you get? 1.5. So you get C1, H 1.5, and O1. What do we do at that point? Multiply them all by 2. So you get C2, H3, O2. Any questions about how to do the first one? Okay? Marissa, how do you feel about that? Okay? So, number 2, find the molecular formula. So we take the mass that's given, which is, and we divide it by what we add up. What do we add up? Okay, so the CH2. So Xavier said the C had how many? And the H had how many? So the mass is 12. The mass is 1. We get 12. We get 2 for a grand total of 14. So 70 divided by 14 is, all right, that means the formula was what? Reduced by 5. So now we're going to do what with the 5? Multiply it by 5. So CH2 to multiply by 5 is C5, H10. Any issues with either question? No? All right, let's talk homework. See what kind of questions we have about our homework, if any. All right, so question 10C was the first one, right? All right, so there's 3 separate answers in 10C because there's 3 elements. So 10C's first answer for magnesium would be somewhere around 41.6, 42, something in that range. All right, the second answer in 42 or 10C would be somewhere in the ballpark of 54.8, 55% for oxygen. And the last one, hydrogen, somewhere in the ballpark of 3.5. You might have rounded it down to 3 or up to 4%. Any questions about that one? Need me to work it? Okay. The next one, what did we jump to? 14? Okay, 14 would be AgNO3. All right, 15 would be C2H6O. Okay, C2H6O. There's no on the end of that. And then 16 NaNO3. And then we jump to what? 18B? 18B C6H12O6. 18C C6H10O4. And then the last one is 19. You had to find 2 answers. You had to start by finding the empirical. And the empirical would be P2O5. And then you jump to the molecular, which is P4O10 for the final answer.
So you had to do 2.
What?
So you had to do 2.
Well, you had to start with the empirical. So, yes.
You do 19.
Sure. All right. In 19, they give you just information to find the molecular. So they give you the mass, and they tell you the mass outright is 284U. Okay? So we're going to need that, but we can't use it because we don't have the empirical formula, right? So we have to start with our 43.5 grams of P and our 56.5 grams of O. So we got to take these two numbers and we've got to change them into an empirical formula first because they didn't give it to us, right? So moles on the bottom. I should say on the top. I think I said on the bottom. All right, so 31, 16. Calculate our moles. Let's see what we get. 43, whoops, where's that? 43.5 divide 31 is 1.403 moles. 56.5 divide 16 is 3.53 moles. All right, Jade, who's the smallest? So we're going to divide there. And we get 1.403 here. And we're going to divide. Tell me what you get. Okay. So when I write the formula, I have P1 O 2.5. So what do I do when I get that? So I get P2 O 5. That is my empirical formula. Okay? The question was the molecular formula. So now I have to take this number up here and this, and I got to do the second piece. Okay? So I'm going to take the 284 and I'm going to use that P2O5 to find my molecular formula. So what do I do now?
You have to find what is it called? The molar mass.
You can call it molar mass, yes.
Of the one.
Yep. So P has 2. Make that a little higher here. O has 5. So I'm going to use whole numbers because it's easier on my math. 31, 16. So that'll be 62. That'll be 80. That'll be 142. So where am I going to put that 142? And so when I divide here, I get 2. So what do I do with that 2 once I get it? You do. So you're going to get P4O10, which is the answer. Okay? Anybody else? Question? Yes, sir.
14.
Yeah.
I think it's the right number for
Okay. So you had 63.50 grams Ag, 8.25 grams of N, and 28.26 grams of oxygen. And I went ahead and changed the percent to grams, like I'm sure you did. 16 grams, 1 mole. 14 grams, 1 mole. 107.8, 1 mole. All right, do you have moles that look anything like what I have?
Yeah.
Okay, so we're dividing by the smallest. So 0.589 is 1, 0.589 is 1, 0.589, 1.766 divided 0.589 is, I got 2.99 when I divide. What's 2.99?
3.
Shh, y'all stop yelling across the room. 2.99 is 3. Okay, what'd you get when you divided?
I got like 0.003.
I don't know unless you flip the numbers.
Yeah, I don't know how I get that. Okay.
Yeah, I don't know either.
Can you do number 15?
Yeah? You do something similar and flip something? All right. So 52.20 grams of C. Those of you who are talking, stop. Even if you don't have a question, be patient with your classmates. 34.80 grams of O. Catch up on the open, Andy, while we're doing this. If you don't have any homework questions. At least you're not going to have to miss any of the lab. Now, if Samaria will be this fast, you won't have to either. All right, what are we dividing by? Okay. That's going to be a 2, that's going to be a 1. And 13 divided by 2.175 is 5.97, which is a what?
Oh, 6.
So C2H6O. You put 1 there, makes you happy.
I put something wrong for oxygen.
What'd you put?
I don't know. I guess I typed it in the calculator wrong.
That could be. If you don't get a whole number, you get something kooky, go back and check your masses, then punch it in the calculator again and see where you went wrong. Baden, take those earbuds out. All right. Any other homework questions? Well, I'm writing it on the index card right now, but it seems stupid. Okay, that's fine. Okay. That's fine.
You know what I'm saying?
Yeah, we'll do it any way you want.
Yeah.
Okay.
I just want to get a feeling.
Okay. I got you. I got you. Okay. All right. How many people do I have?
Hang on.
An even number. You got to be your partner today.
What we doing Friday?
Some of the balanced equations, all I can tell you, probably word equations at this point in time.
That's what we're going to
Go where?
do.
It'll be on YouTube and you got to catch up. That's all I can tell you. I will be here Friday. Here next Monday. Okay. All right. You need, for the purposes of today, first of all, you're going to need paper. Okay. Those of you who write really large might need 3 sheets. Those of you who don't write really large, you're probably going to need 1 to 2 sheets. All right. You must show me your work for credit. If all I get is an answer or a mishmash of work that's not complete, you're not getting all your points. Let me be clear. Okay? You must show me your work. So if I go back here, you see how Ms. Wall showed the work for the empirical formula? I expect to see your work for the empirical formula. You see how I showed the work for the molecular formula? I expect to see your work for the molecular formula. Without it, you're not getting full credit. Now, you have to do 2 things on this lab. You have to calculate and you have to name. We're tying together what we learned to do yesterday with what we learned how to do last week. You should have, aside from paper, a periodic table and your blue oxidation sheet. You're going to need the periodic table for the masses. You're going to need your oxidation sheet to name with. Okay? That is the only supplies that you get other than a partner. Okay? We have 16 people present and accounted for. Marissa did a fabulous job catching up last night on YouTube, so she is able-bodied and ready to participate today. So we have 16 able people to participate who know how to calculate empirical and molecular formulas, and theoretically everybody knows how to name. I am not telling you which system you have to name with. If it is ionic, what is the only system we can use? Okay. If it's covalent, you may choose. I will not specify. You may choose whichever system you prefer. Okay? That's all I'll say about that. Now, you must show me the work. Both partners must show me the work. You may not say, I'll do number 1, you do number 2, you do number 3, I'll do number 4. Everybody does their own. You get to consult and make sure everybody's work is correct. 1 through 5 are worth 20 points. The bonus is only worth 5 points. So if you choose to do the bonus and skip number 5, the best score you can get is a what? Very good. So I don't personally think you should do the bonus and skip number 5. I do 1 through 5 first, then try the bonus. Now you get 45 minutes total. So check your clock. I'll keep an eye on my watch. You get 45 minutes total. Now, here's the other part. You got to space yourself out in the room. You only got a partner. It's not a group project of 4. If you talk to other people, both groups get 0s. Do not consult with another group. So, hold on, Tomas, I'm still talking. You know I like to talk. So, if a group is at this table, only one group is at that counter. Another group can be at that counter. There are 6 counters. There is the table there. As long as we have some people on the far side of the little rollable table, we could use that one. We have only 8 groups in here, so we should be able to do that fairly well in like 33, which is a little big. Okay? So spread yourselves out. If you want to sit, I don't have enough stools. You can pull the chairs together in the middle of the room so that you're spread out. I should not be able to make out your conversation at my desk, because that means you're sharing with another group. Am I clear? Okay. 45 minutes. Let's start. That's 11:15 for those of you who can't tell time. All right, everybody got a partner? There you go. Wait and just pull yourself out there. Very good. And you got a chair. Your old one? Yeah, even for the commercial one.
How many responses then?
So what now? I'd leave it at 35.45. I wouldn't round that to all number. To what? Yes. Tiffany, you want more from the left? You only have until 11:15, but if you don't finish it, you can work on it at lunch if you want to come back. All right, you get a periodic table in your blue chart. All right, you need paper, okay? If because you gotta show all your work. Okay, you gotta show me the work from empirical and molecular formula. You gotta write the name, you gotta write for both of them. Now, if it's an ionic compound, you can only write with what system? That's right, stock system. If it's covalent, you can name it with or the stock, name it with either one. Now, if Samaria happens to get back from the ACT, which is possible, there she is. Good job, Samaria. Tiffany just happened to walk in, grab your 2 charts. You guys have about a half hour that you can work. And if y'all don't finish, you can come back during lunch. That way you don't have to come back after school. Grab your charts. Come on. Jump, jump. Yo, Samaria. Dave.
I'm trying.
I'm trying to keep you from having to come back after school. Let's go. Y'all are only 15 minutes behind everybody else. So that means you only get an additional 15 minutes of lunch. Now, y'all can't talk to any other groups. You gotta stay spread out. You cannot be at a counter with anybody else. You can pull some chairs out here in the middle, or you can go sit at the back. Whichever one you want. Okay? Now, you gotta have paper. Can't have your notebook. You only get 2 charts. No notes. You gotta have paper. Probably, if you write big, you're gonna need 3 sheets, otherwise you need 2. As long as you don't get crazy with your size. Alright, you gotta show all your work for empirical and molecular formulas. Okay? All the math work, you can't divide them up. You both gotta show all 5 problems. Bonus is extra. These are all 20 points each. That's only 5. So don't do that in lieu of these 5. Okay? For empirical, like I told her, or molecular, it doesn't matter which one. If it's an ionic compound, you can only name it with which systems.
I just do all of this stuff.
Okay.
Yeah,
But
that's
if
what
it's,
I'm gonna do too.
but if it's a covalent compound, technically you have a choice. I won't tell you which one you got to name. Okay? You only get 45 minutes. Y'all are at 30, so you could have 15 additional at lunch.
I take six.
Depends.
Yeah.
Depends on what you're doing. About what we had to do with finding the original occupational license. Does that help? Original occupation. Yes, 399.91. Finally. You got it. Oh, that's back 12. That's all. Oh, half a meter.
So it's all very divided.
Depends. Remember when we were naming, you had to have the original oxidation number. Does that help? They have to have the original oxidation number. Does that help? Yes. You done? Possibly, yes.
Are you gonna take these up, or are we going?
Oh, stack. Let's make a stack. Those of you who are done, just sit and be patient. Those of you who are not done, cannot talk to those people who are done. Talk to your partner only. That way I know you stay out of trouble.
Mine's like I haven't even started, but I have all the exams in my life. It's like military. Oh yeah. Because I was like, it is exciting. I was like, no, it's so hard. I'm just thinking about this. And I'm gonna do like I'm sorry. I literally have everything right now. People that I know for me, some of my class, and I was like, I'll just do it myself. Is there little questions? No. Up to chapter 2. I don't know if I was supposed to get it, but I haven't. I went for
When you name using the stop system, you have to use the original oxidation number.
Okay, that's what
Stop.
and then I went to, I saw one of the novels, I was like, well, I got all and I don't really use notes. I look for
Yeah, I don't think it is.
No, it's fine.
Yeah, did anybody take a picture of the old section 143?
Go ball. You like me, man. Hey, bro. If I go to the field, you gotta go. Come on, bro. That's what we want to do. People that are bro, come on, bro. Come on, bro. That's a big deal. That's a big deal, bro.
Please.
You should lose. You gotta go walk the stage. If I go undefeated, you gotta go walk the stage.
Non-special.
Come on, bro. Alright, if I go, I get. If I get first, well, it's gonna be hard. If I get first, at least you gotta go walk the stage. Come on, bro. Come on, bro.
Y'all done? Someone wait on one time.
If I said if I was first, at least you gotta go walk. It doesn't. What about the fuck y'all? I'm going wrong. I'm gonna say, you got to your ball first.
I'm wrong. What do you think?
Long time ago. First, you do come on, bro. I get
Is it you? That last one.
okay, come on. Come on, bro. Come on, bro. Come on. It's gonna be hard, man. Come on.
I know, I mean, I'm walking. That would be you. Yeah, it was.
All right, so I have one group still working. While they're taking their last 3 minutes to finish, if you have a calculator, unless you're going to need it to multiply numbers today, like 6 times 4, 3 times 2, 4 times 5, you can put your calculator up, okay? There's one left on this counter that somebody left behind in Eduardo. You're not going to need any charts for what we're going to do the rest of today. You're just going to need your notes.
Look. That's how bored I got. How much did you read? I don't know. But it's hard.
I'm just enough to ask.
They have these things that Go, sit down. Hold on, stop. Everybody's doing you to stop. You need to sit down for real. Stop.
Bruh. Bruh,
Step on you.
that was disrespectful.
You disrespect.
Don't stop arguing over there. All right, gentlemen, y'all are down to 2 minutes, so put down what y'all want me to do in those final 2 minutes.
You really gonna have to take off on this.
I need to make more copies of that syllabus, that thing for course this afternoon.
I did not touch you.
I saw mine.
Pick it up. Go ahead, pick it up.
Looks like 1 to 50.
You get it going. You get it going.
Oh, baby.
Out there.
Still have some calculators out. So some people feel like they need them to multiply today.
Boy.
Really? Y'all can't multiply 4 times 2, 6 times 4 without having a calculator?
The basics.
Really? Give me my other 2 calculators.
What? I just don't want to get up.
Okay.
Understand.
All right, so all of the stuff that we just practiced, you will see on quiz tomorrow, okay? And then you will not see it again for about, I'm guessing 2 weeks-ish before it'll appear on the test, okay? So the stuff that we just did will not be on the next test, all right? This stuff will be on quiz tomorrow, and then it's going to disappear for a couple weeks before we see it on a test, all right? And then it'll be on strictly a math stoichiometry test. Now, the next test is going to be on chemical reactions. So, we're going to start chemical reactions today. Depending on your 8th grade experience, some of you will have had some exposure to today's topic. Those of you who had a really crappy 8th grade experience will have seen none of this. All right, my physical science folks who've done physical science will have seen some of this before. Those of you who had a pretty good experience in 8th grade because you had a real teacher will have seen some of this before. Those of you like Tiffany who are shaking your head, I had a sub. No, you will have not seen any of this other than, whatever y'all did with a sub of the book. All right, now, first of all, everybody in here at some point should have talked about the 3 essential parts of a chemical equation. So if we have something that looks like this, everybody should be able to identify 3 major parts in this reaction. Can anybody tell me what the 3 parts are? I'll take anything you recognize or know. The what? Yes, but that's not one of the parts. Products would be one of them. Could anybody tell me where the products are? There you go. All right. Everything on the right side. Okay. After
Is that
Fe2, that's an S. That's an S. All right. After the arrow are the products. Now, I wrote after the arrow today, just because some of us struggle with right and left. Now, this is referred to as the right side, for those of us who struggle with that. You're going to hear me refer right and left often. The right side of the arrow is the product side. Okay? They are the products. They're formed, produced. Okay? We often refer to these as formed or produced. That's why they're products. Okay? Anybody else got something else they remember?
Reactants.
Reactants, good. All right, so the reactants are always before the arrow. Or you can think of them as on the left. Here, let me write that up there like I did on the last one. Okay? They're on the left side. These generally react or mix together. All right, there's one final thing you should have talked about or been exposed to in this reaction that's a key word you're going to see over the course of time, or that we're going to refer to. It's the name of the arrow. Why? Yeah, a why? Nobody knows? Really?
What's the next letter?
I?
Yield.
Yes. It's called the yield sign. Okay? Now, all of these little doodaddies, have I heard of those? Know what those are? Those are states. We're going to talk about those in a few minutes.
Oh, solid.
Mm-hmm. Yep. Now, we're going to talk about the symbols you're going to see in the equation, and we're going to talk about the one rule that governs balancing today. And hopefully we'll have a little bit of time to talk about some balancing before you get out of here, because our class is a little longer than third, so we should have a little time to get started on that. Does everybody have what they need off the board? All right. Now, this is the section of the test that people do the absolute worst on. It's 6 points when we take the test, because we talk about it today, and people never study it again. And I will tell you the day before the test, I will remind you through the course of the next 2 weeks that it's on the test. People still won't study this part, even when it's on the test. And then the 3 symbols that I select out of this, people get them all wrong. 2 points each, okay? I'm telling you, it's on the test. Study it for a change. Now, in the equation, there are lots of symbols that we're going to use. Now, I'm going to strip the equations down to the barest of bones, so all this stuff is not clutter over the course of the next week. As we cruise through the semester, though, I add the pieces back in, so by the end of the semester, it's all there by June, okay? So when you see this stuff, you're not like, oh, what the heck is that thing? Because we've been using it since day one. Now, this, of course, was what? That was the yield sign. But what if I use 2 arrows, which we're going to be using close to about week 15? What are 2 arrows going to mean? This means the reaction is a reversible reaction. So when we study equilibrium, we'll have a reversible reaction. Now, those aren't the only arrows we will see in a reaction. We might see something like CO2, and they'll have an arrow going up behind it. That means a gas is released. Or you might see something like a down arrow. That means a precipitate is formed. All right? Be right back. Yeah, all that crap.
I got a 7-page application to fill out.
All right, somebody tell me what a precipitate is.
Water.
Y'all are going to start contributing to my alpaca fund with those kind of answers. No, I'm thinking about buying one because I suck at this job some days. If y'all think precipitates are rain, I am not doing a very good job after 20 days. That's right. It's a solid formed from two liquids. So this was a solid that formed when y'all mix two liquids. And that's what that down arrow means. This is a solid. Okay? So if we put a down arrow behind that compound, that's telling you that's a solid. Okay? It's not rain. Huh? Now.
You said it too.
No, you just said
Oh yeah, I said something.
All right. Now, these refer to the what?
The state.
The states. And I don't mean North Carolina, South Carolina, and Virginia. All right. So, huh? So what is S? L? G? Good. Those we always know. Are those the ones on the test? No. I'm not putting those three on the test.
You might as well. That's what we know.
Why do you think people get them wrong? I don't put the things y'all know on the test. I put the things that are new to the course. Y'all should have known those in middle school.
That's your fault.
We didn't know that in middle school. We didn't have a teacher.
I had 4 teachers throughout my school. I had 4 teachers throughout my 8th grade year. Well, he just didn't he always collect apples too?
And the trash can.
Yeah. He was like waist deep in there.
Yeah, he said that was wasting when the horses could eat them.
Well, it makes complete sense.
Oh.
Yeah, sure. Yeah.
It does. It's just funny. He was like how his body was in the trash can.
All right. So CR. What does CR mean? Anybody know? Okay. This stands for crystalline solid. Okay. Now, there are 2 types of solids we will talk about later in the semester, and crystalline is one type. This is like salt or sugar, okay, as opposed to amorphous, which is like wax or plastic. AQ is one that everybody always struggles with, and it's one that we use all the time in our everyday lives. It means aqueous, which means dissolved in water. Now, the only thing that we use that's not aqueous is literally water. If you're drinking water in a bottle that you got out of the water fountain, perhaps a precipitate that you might think of as rain, sleet, snow, or something else, or maybe you bought some Aquafina or some Dasani because you're a water snob, then you're drinking a liquid up there at the top of the board. But if you're drinking anything else, you have some tea, some juice, you've got a soft drink like I prefer, you like milk, all of those things are aqueous. Whatever you have is dissolved in water. If you like Gatorade, Kool-Aid, whatever contraption they're serving down there in the cafeteria. It's aqueous. It is dissolved in water. Okay? We all drink aqueous liquids unless we're drinking plain what? Water. Okay? Water is the only one that fits here. Most of us drink this. Okay? Now, let's see. What have I forgotten? Stuff written on the arrows. Suppose we write something on the arrow, like a triangle. What's a triangle on the arrow mean? What? What'd you say? You might have been right. I didn't even hear it. All right. It means heat is added. Okay. Well, I couldn't have told you if you were right or wrong if you don't say it. Okay. Sometimes we write compound names. Okay. Such as that. All right. That means a catalyst is added. Anybody remember what a catalyst is from biology class? That's right. And that's just added to speed up the reaction. Later in the semester, we'll talk about things that affect reaction rates. And we'll talk about these again. Okay? Makes the reaction go faster. Now, you might also have a number, such as 2 ATM. That means that we had to add or increase pressure to 2 atmospheres. Okay? But when they put things on top of the arrows, they're telling you they added something to the reaction. The triangle is heat. The MnO2 is a catalyst. Now, is MnO2 the only catalyst? No, it's just what I put there. Okay? So any formula that they write on the arrow is going to be a what? It's going to be a catalyst. You don't have to memorize MnO2. All you have to know is if they write a formula, it's a what? It's a catalyst. If they put a number here, it's a what? It's an added pressure. You don't have to know 2 ATM. If they have a number, it's an added pressure. Okay? Now, they could put a temperature there, but more often they're going to put a triangle for added heat. Now, the only question is, has my old brain forgotten anything? And I think I have the, oh, I got the right notebook. Let's see.
Wait, all the symbols gonna be.
No, I'm going to pick 3. Let's see. Have I forgotten any? Got that one. Nope, I got them all. All right. So what is the only law that we have to use to balance? Now, you've been learning this law, I'm guessing elementary school. It's been a long time. Y'all been learning this law. So somebody tell me what this little itty bitty law says that you've been learning.
Nothing can be destroyed, but it can only be transferred.
Not bad. Not bad. Okay? All of these laws say the same thing. Okay? It could be the law of conservation of matter, the law of conservation of energy, the law of conservation of momentum, the law of conservation of whatever we want to put right there. All you have to change is the first word. Mass cannot be created or destroyed in an ordinary chemical reaction. It is transferred. What does this mean for us, though, in terms of balancing? It means if there's 4 FEs on the left, you need 4 FEs on the what? On the right. That's the whole premise behind balancing. Your job is to make it work. Okay? So if there's 4 or something on the left, you got to get 4 on the right. If there's 3 oxygens on the left, you got to get 3 oxygens on the right. Okay? Because according to that law, it can't be created or destroyed. So if there's 5 of something, you got to end up with 5 of something. You can't start with 5 and end with 3. Okay? Does that make sense? Okay? Now, the process is trial and error. I can give you a whole bunch of rules to walk through the balance. It's still trial and error. Okay? I can do it fast because I've done it for 30 plus years. Some of you are going to gravitate to it like fish to water. And you're going to sit here tomorrow and you're going to go, dang, why can't these people get it? And some of you are going to, after 20 minutes, be like, that's the hardest crap I've ever done in my life. Be patient with yourselves, okay? Those of you who are the fish to water, be patient with your classmates, okay? You got me? Some of you are not going to get it fast. Some of you are going to get it really fast. Be patient with each other. Now, let's do 1 or 2 just to make sure we have the idea of how it works. And then I probably won't even give any balancing for homework tonight. Just because I'm nice that way. Your homework tonight is to make sure you can do your stuff for your quiz tomorrow. I want all hundreds. Let's say this, 90s and above. I give you a little bit of leeway. All right, so when you look at this, first of all, we're going to work with 2 kinds of numbers. All right, we're only going to get 1 because I forgot that part. What are the 2 kinds of numbers we got to deal with? These are called what? Math class, what kind of numbers are these called? These are called subscripts. These tell us the number of atoms. Okay? The numbers we're going to put in are called coefficients. Okay? Now, what do these coefficients do? When I put a number in front of a compound, like I put a 2 in front of Fe2O3, this number multiplies and distributes, okay? Just like math class. This is like having 2 times x plus 4. What happens in math class if I have this? What does it become? 2x plus what? Same thing in chemistry class. How many irons do I make? 2 times 2 is, so I get 4 Fe's. I get how many O's? I get 6 oxygens, okay? That's how that works. Now, we have to get the same number on both sides. I'm just going to pick oxygen to start, just to give us an example today. How many O's are here? How many O's are here? Can we all agree that there's no number I can put here that will multiply by 2 to give me 3? There's no number I can put here to multiply by 3 to give me 2. So what number do 2 and 3 have in common that I might be able to use? 6. So how can I get 6 O's right here? Times 3. So 3 times 2 makes 6 oxygen, right? So how can I get 6 oxygen here? Add a 2. 2 times 3 makes 6 oxygen. Now, because I put that 2 there, what did I just say happened when I put that 2 there? It distributes. So that 2 also goes here. So I made how many irons? I made 4 irons. Now, these numbers multiply and distribute. I have how many Fe's right here? 1. These numbers multiply. What times 4 or what times 1 will give me 4? So I have to put a 4 there. 4 times 1 will give me 4. and my equation is balanced. Questions? Now, we will practice this tomorrow after the quiz. Your homework is to study for your quiz so that you do well. I do not. What is on the quiz? Xavier says. Somebody tell him what is on the quiz tomorrow so he knows what to study. Molecular formulas. Empirical formulas. Notice I'm still staring at you like y'all are nuts. So there must be something that you're missing.
That's it. That's it, right?
Easy killer. Molecular formulas, empirical formulas, and no, there's one other kind of problem we learned to do. It's the little percenty thing, Stephanie says. It's called percent composition. A little percenty thing. You were